Good morning, students. In the last class, I was telling about Rutherford's alpha scattering experiment. You learned observations and experimental conclusions of Rutherford's alpha scattering experiment. And today I want to tell about the Bose atom model. Bose atom model. See, Rutherford's atom model. Thomson's model was the first atom model, and second one is Rutherford's atom model. And in Rutherford's atom model, it was said that an electron of hydrogen atom, it is continuously revolving around the circular path around the nucleus in the circular orbits with the help of centripetal force. And see, many scientists, they argue that if an electron is, this is the nucleus and these are the circular orbits. Here one electron is revolving. This is the electron. Imagine this is the electron. It is revolving in this path around the nucleus. This is the nucleus. So if it moves continuously around the circular path, around this circular orbit, what happens is, here see, Rutherford said the electron in its orbit where it is revolving, there only it is giving out electromagnetic radiations, that is energy. In the orbits only they are emitting electromagnetic radiations. So if an electron emits energy while revolving in the circular orbit in an atom, that goes on losing its energy decreases. If an electron is giving out the electromagnetic radiations or energy in the form of photon or in the form of X-ray or in the form of gamma ray, ultraviolet ray, visible ray, infrared radiations, or maybe anything, here the electron loses its energy continuously. So what is happening? Finally, after losing all the energy, the electron finally it falls into the nucleus, and thereby the atom becomes unstable. Because when the electron, negatively charged particle, falls into the nucleus, positively charged nucleus, atom may explode into pieces. Here Rutherford's atom model, it fails to explain the stability of an atom. It fails to explain the stability of an atom. Next comes a famous scientist, Niels Bohr. So by seeing the drawbacks or demerits of Rutherford's atom model, he developed an atom model which is also called as modification of Rutherford's atom model. So here Bohr's atom model is called modification. It is the modified atom model of Rutherford's model. It is the modification made to Rutherford's atom model. So what are the, now let me tell about postulates of Bohr's atom model. Postulates. You know that postulates are highlights. Highlights are positive information or merits or advantages of atom model. So here postulates of Bohr's atom model means, here postulates are telling what are the highlights of Bohr's atom model. So postulates, salient features ಅಂತ ಬರುತ್ತೆ. Postulates are ಏನಂತ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ನಾವು? It is the information given by Bohr's atom model. Postulates, salient features, merits, advantages ಇವೆಲ್ಲ ಒಂದೇ meaning ನ ಕೊಡ್ತಿದ್ದಾರೆ. Right? So what is the first point of Bohr's atom model? Here the first point is, same here. The first point is exactly similar to the point of Rutherford's atom model. So first point here, all the electrons are revolving. All the electrons are revolving in a circular orbit with the help of centripetal force. That centripetal force is given by the electrostatic force of attraction between positively charged nucleus and negatively charged electrons. So see here, let me tell about postulates of Bohr's atom model. The first postulate is an electron is revolving around the nucleus of an atom in circular orbits. The necessary centripetal force is given by the electrostatic force of attraction between the nucleus and the electron. So what is the first statement is saying? The electron, see, especially Bohr's atom model, Rutherford's atom model, they are explained or they are suggested only for hydrogen atom, not for helium or for carbon or for oxygen or for nitrogen or any other atoms. Here these models are mainly specially developed for explaining structure of hydrogen atom. So in a hydrogen atom, there is only one electron and only one proton. How many electrons are present in hydrogen atom? Only one electron is present. So while writing the postulates, you must write an electron, the electron, not electrons, because there is only one electron in the hydrogen atom. So here first point, that a single electron of hydrogen atom, it is revolving around the nucleus in a circular orbits. In circular orbits, it is moving with the help of centripetal force. See, to move around the circular path, electron requires centripetal force. And who is giving that centripetal force? That centripetal force is provided by the electrostatic force of attraction present between nucleus and electron. So the electrostatic force, which is, see here, force of attraction, electric force of attraction or electrostatic force of attraction. Why it is called force of attraction between nucleus and electron? Because nucleus is positively charged, electrons are negatively charged. Therefore, there exists a force of attraction present between nucleus and the electron. So that is giving the nuclear centripetal force, right? That electrostatic force of attraction is giving the centripetal force. Therefore, an electron is revolving around the nucleus of an atom in circular orbits, and the necessary centripetal force is given by the electrostatic force of attraction between the nucleus and electron. Understood? First point, what it is saying, the electron in hydrogen atom, there is only one electron. That electron is revolving in that atom around the nucleus in the circular orbits. And that is rotating with the help of centripetal force. Therefore, here the necessary centripetal force. Then why it is necessary for revolution of the electron around the nucleus? That necessary centripetal force is given by the electrostatic force of attraction present between the nucleus and the electron. Electrostatic force of attraction is given by nucleus and electron. Therefore, it is present between these two things, and this force is giving the centripetal force, and with the help of that centripetal force, here the electron is revolving. So this is the first postulate of Bohr's atom model. Second postulate, the electron revolves only in those orbits where the angular momentum of an electron is equal to integral multiple of h by 2 pi. See, if I said only one electron is present in the hydrogen atom, and that electron is revolving around the nucleus. Where it is revolving? In which orbit the electron is revolving? First orbit around the nucleus, first orbit or second orbit or third orbit or fourth orbit or fifth orbit. Where it is revolving? For this question, answer is here. Here that electron revolves. The electron revolves only in those orbits. The electron revolves only in those orbits where the angular momentum, one condition is there. To find where the electron is present, you must know one condition. That condition is here the electron revolves only in those orbits where the angular momentum is integral multiple of h by 2 pi. Where the angular momentum of electron is equal to integral multiple of h by 2 pi. Right? So here that is the angular momentum. Electron the angular momentum ಯಾವುದು equal ಇರಬೇಕು? Integral ಅಂದ್ರೆ number integers. N is integer. Integral means integer 1 2 3 4 5 like that. Integral multiple of h by 2 pi. That is L equals to here angular momentum is L. L equals to mvr. Formula for angular momentum mvr. So here I am writing mvn. V to the base n. So what it means? Velocity of an electron in nth orbit. V to the base n means velocity of an electron in nth orbit or an radius of the nth orbit of hydrogen atom. Radius of the nth orbit of hydrogen atom equals to integral multiple of h by 2 pi. So where this condition is satisfied, in that orbit you can imagine the presence of electron. Where it is electron, where it revolves? In the first orbit or second orbit or fourth orbit or eighth orbit or fifth orbit or sixth orbit or seventh or ninth or 11th or 12th. Where it is revolving means where the condition, that is angular momentum of electron, angular momentum of an electron is equal to integral multiple of h by 2 pi. Where the angular momentum of an electron is equal to integral multiple of h by 2 pi. There in those orbits here electron is revolving. So condition is L equals to, symbol for angular momentum is L equals to mvr. M v to the base n r to the base n equals to nh by 2 pi. mvr equals to nh by 2 pi. mvnr equals to nh by 2 pi. Where m is mass of an electron. What is m here? Mass of an electron. Vn velocity of an electron in nth orbit of hydrogen atom. Rn radius of the nth orbit. N is integer. It is also called as principal quantum number. N is called as principal quantum number or integer or number of orbits. N is called by the name principal quantum number ಅಥವಾ integer ಅಥವಾ number of orbits. First orbit or second orbit. H is Planck's constant. Pi is 3.142. Right? This is the second postulate. Third postulate, the electron do not radiate energy while revolving in selected orbits. Therefore, the selected orbits are called stationary orbits. This is the main modification given by the Bohr compared to Rutherford's atom model. Rutherford's atom model electrons are radiating energy while revolving in circular orbits. ಅವೆಲ್ಲಿಂದ ಎಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಇದ್ದಾವೆ, ಯಾವ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ revolve ಆಗ್ತಾ ಇರ್ತಾವ, revolution ಆಗ್ತಾ ಇರ್ತಾವ, there only they are giving out the electromagnetic radiations. This was the statement of Rutherford's atom model. Here Bohr corrected that one. The electron is not giving any energy. It is not radiating energy. The electron do not radiate energy while revolving in selected orbits. Therefore, the selected orbits are called stationary orbits. ಅವುಗಳ ಏನಂತ ಕರೀತಾರ, ಇವು ಎಲ್ಲಿ ಇರ್ತಾವೆ, ಎಲ್ಲಿ ರೆವಾಲ್ವ್ ಆಗ್ತಾ, ಎಲ್ಲಿ ಮೂಮೆಂಟ್ ರೊಟೇಟ್ ಆಗ್ತಿರ್ತಾವೆ ಯಾವ ಸರ್ಕ್ಯುಲರ್ ಆರ್ಬಿಟ್ ನಲ್ಲಿ, they are not radiating. Radiating means emitting. They are not emitting energy. Therefore, those orbits are called stationary orbits. ಅವುಗಳನ್ನು ಸ್ಟೇಷನರಿ ರೆಸ್ಟ್ ನಲ್ಲಿರೋ ಆರ್ಬಿಟ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಆರ್ಬಿಟ್ಸ್ ಕೂಡ ಎನರ್ಜಿನ ಕೊಡಲ್ಲ, ಆರ್ಬಿಟ್ ನಲ್ಲಿ ಎನರ್ಜಿ ಎಮಿಟ್ ಆಗ್ತಾ ಇಲ್ಲ. ಸೊ therefore they are called stationary. Stationary means not moving, not fixed, at rest. They are at rest, stationary orbits. So third postulate, the electron do not radiate energy while revolving in selected orbits. Therefore, the selected orbits are called stationary orbits. Selected orbits ಏನಂತ ಕರೀತಾರ? Stationary orbits ಅಂತ ಕರೀತಾರೆ. Right? Stationary orbits ಅಂದ್ರೆ fixed orbits. ಅವು ಯಾವ ಚಲನೆ ಆಗದಂತ ಆರ್ಬಿಟ್ಸ್, ನಿಂತಿರುವಂತ ಆರ್ಬಿಟ್ಸ್. ಸೊ ಎದಕ್ಕಂತ ಕರೀತಾರೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೇ ಎನರ್ಜಿ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಟ್ ಮಾಡಲ್ಲ, ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವುದೇ ಶಕ್ತಿಯನ್ನು ಹೊರಹಾಕಲ್ಲ ಅಲ್ಲಿ ಅವುಗಳಲ್ಲಿ ತಿರುಗುವಾಗ. ಸೊ ದೇ ಆರ್ ಕಾಲ್ಡ್ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ಸ್. Fourth one, the electron emits energy when it jumps from ಯಾವಾಗ emit ಆಗುತ್ತೆ ಅನ್ನೋದು fourth one. When the electron is giving out the energy, here the electron emits energy when it is jumping from higher energy level to lower energy level. This energy is in the form of photons. This energy is in the form of photons. Photons are having the energy E equals to E of minus EI. Photons are having the energy E equals to E of minus EI. And frequency nu equals to E of minus EI by H. And frequency here, see, when electron jumps from higher energy level, second orbit to first orbit. Here second orbit is higher energy level, first orbit is lower energy level. When electron jumps from third orbit to second orbit, third orbit higher energy level, second orbit lower energy level. Fourth orbit to second orbit, fourth orbit is higher energy level, second orbit is lower energy level. So when electron jumps from higher energy level to lower energy level, it emits the energy. That energy emitted by the electron is in the form of photons. And photons, these photons are having the energy equals to a difference between the energy of higher energy level and lower energy level. That is E2 minus E1. If it jumps from second orbit to first orbit, E2 minus E1. If it jumps from third orbit to first orbit, E3 minus E1. Fourth orbit to first orbit, E4 minus E1. Fourth orbit to second orbit, E4 minus E2. When it jumps from final orbit to initial orbit, E equals to E of minus EI. Here final orbit may be fourth orbit, or second orbit, or third orbit. Initial orbit may be first orbit or second orbit. Right? So the total energy of the emitted photons is equals to difference in energy of higher energy level where the electron is jumping and initial energy level to which orbit it is jumping, it is coming, to which energy level it is coming. So here E equals to E of minus EI and frequency nu equals to E of minus EI by H. Frequency nu equals to E of minus EI by H. See, this is taken, energy of photon is equals to E equals to H nu. Energy of the photon ಏನು ಬರೆದಿರೋ E equals to H nu. So ಇಲ್ಲಿ E ಅಂದ್ರೆ E of minus EI, H nu, E of minus EI equals to H nu. So nu frequency nu equals to E of minus EI by H. E of minus EI by H. So where E of is energy of final orbit, EI is energy of lower orbit, nu is the frequency of emitted photon, H is a Planck's constant. H is the Planck's constant. What is the value of Planck's constant? 6.625 into 10 to the power of minus 34 joule second. 6.625 into 10 to the power of minus 34 joule second. That is the energy Planck's constant, value of Planck's constant. So these are the four important postulates of Bohr's atom model. So according to first postulate, here one thing you can remember, here centripetal force is equal to electrostatic force of attraction. Because electrostatic force of attraction is giving the centripetal force. So what you can take, Fe equals to Fc. Fe equals to Fc. Here Fe means electrostatic force between nucleus and electron. Fc means centripetal force. So how to find this one? By using Coulomb's law. By using Coulomb's law you can find the electric force. Coulomb's centripetal force mv square by r. mv square by r. Formula for centripetal force mv square by r. And second postulate, where the electron is revolving in which orbit? In which orbit? The condition L equals to m Vn Rn equals to nh by 2 pi. Vn andre v to the base n, velocity of an electron in nth orbit. ಇಲ್ಲಿ Rn andre radius of the nth orbit. Where this condition gets satisfied, in those orbits the electron is revolving. So what is the third one? Here electron do not radiate energy when it is revolving in selected orbits. ಈ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗುತ್ತೆ ಆ ಒಂದು ಆರ್ಬಿಟ್ ಅಂದ್ರೆ ಸೆಲೆಕ್ಟೆಡ್ ಆರ್ಬಿಟ್ಸ್ ನಲ್ಲಿ ಮಾತ್ರ ಎಲೆಕ್ಟ್ರಾನ್ ತಿರುಗ್ತಾ ಇರ್ತದೆ, ತಿರುಗುವಾಗ ಎನರ್ಜಿ ಅನ್ನು ರೇಡಿಯೇಟ್ ಮಾಡಲ್ಲ. ಸೊ ದೇರ್ಫೋರ್ ಆ ಆರ್ಬಿಟ್ಸ್ ಏನಂತ ಕರಿತೀವಿ ನಾವು? ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಯಾವಾಗ ಎನರ್ಜಿ ಎಮಿಟ್ ಆಗುತ್ತಾ? when it jumps from higher energy level to lower energy level, and that energy, emitted energy, is in the form of photons. photons are having energy E equals to EF minus EI, and frequency is nu equals to EF minus EI by H. So now let me tell about one of the important derivation of this chapter, that is expression for radius of nth orbit of hydrogen atom. nth orbit hydrogen atom nalli nth orbit radius game baruthe expression annodana discuss ಮಾಡೋಣ. So consider an electron is revolving in nth orbit of hydrogen atom. Imagine, consider an electron is revolving in nth orbit of hydrogen atom. Let's check. Nth orbit of hydrogen atom. So here, see, this is the nth orbit. Imagine this is the nth orbit and this is the nucleus. Nth orbit, here the electron is revolving. Electron. Vn, and this is Rn. Consider an electron is revolving in nth orbit of hydrogen atom. Let Vn is the velocity of this electron in nth orbit. Velocity of the electron. In nth orbit. Rn, radius of nth orbit of hydrogen atom. M is mass of an electron. M andreno mass of an electron. M is mass of an electron. Vn is velocity of the electron in the nth orbit. Rn is radius of the nth orbit. M is mass of an electron. So now see, radius of nth orbit of hydrogen atom, it is calculated by using Bohr postulates. So from first postulate of Bohr's atom model. What we can write? Fe equals to Fc. Here, this Fe is electrostatic force of attraction between electron and nucleus. Fc is centripetal force. So this is equation number 1. Imagine equation 1. We know Fe equals to, Fe is electrostatic force of attraction. Coulomb's law is not 1 by 4 by epsilon into Q1, 1 by 4 by epsilon into Q1 Q2 by R square. Coulomb's law to ಇಲ್ಲಿ Q1 ಅಂದ್ರೆ ಚಾರ್ಜ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್, Q2 ಅಂದ್ರೆ ಚಾರ್ಜ್ ಆಫ್ an electron, R square ಅಂದ್ರೆ the distance. So first charge of the nucleus is Ze into charge of an electron is E. It is negative, but for the time being you should take positive charge for electron in it. Positive ಅಂತ ತಗೋಬಹುದು. Ze ಅಂದ್ರೆ Z ಅಂದ್ರೆ atomic number ಅಥವಾ number of protons. Z ಅಂದ್ರೆ atomic number ಅಂತ ಕರೀತಾರೆ, number of protons ಅಂತ ಕರೀತಾರೆ. Here Ze represents charge of all the protons. So here in nucleus, protons and neutrons are present. Neutrons are not having any charge, protons are having charge. Therefore here for nucleus, the charge of all the protons is Ze into E divided by Rn square. Ze into E divided by Rn square. Here the distance is radius. This is one charge, this is another charge. So its charge is Ze. Charge of all the protons. Z is proton, this charge, E is charge. So negative charge is the electron ಗೆ, but ನಾವು ಇಲ್ಲಿ charge just simple ತಗೊಳ್ತೀವಿ. Ze into E divided by Rn square. So Fe equals to Ze into E, Z E square. Ze into E, Z E square into 1, Z E square divided by 4 pi epsilon naught Rn square. 4 pi epsilon naught Rn square. This is the expression for electrostatic force of attraction between electron and nucleus. Coulomb's law formula is 1 by 4 pi epsilon into Q1 into Q2 by R square. Q1 ಅಂದ್ರೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಚಾರ್ಜ್ Ze ಇದೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ನಲ್ಲಿ ಪ್ರೋಟಾನ್ಗಳು ಇರುತ್ತವೆ. ಪ್ರೋಟಾನ್ಗಳ ಚಾರ್ಜ್ Z ಅಂದ್ರೆ ಪ್ರೋಟಾನ್, E ಅಂದ್ರೆ ಚಾರ್ಜ್, ಪ್ರೋಟಾನ್ಗಳ ಚಾರ್ಜ್ Ze. ಇದು ಎಲೆಕ್ಟ್ರಾನ್ಗಳ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇರ್ತದೆ, E just right. Ze into E by Rn square. So Fc, centripetal force, mvn square by Rn. Fc equals to mvn square by Rn. So equation 1 becomes equation 1 ಏನಿದೆ, Fe equals to Fc ಇದೆ. So ಇಲ್ಲಿ Z E square divided by 4 pi epsilon naught Rn square equals to V square Vn square divided by Rn. Mvn square by Rn. So you bring Mv square to the LHS and Rn square, carry Rn square to the RHS. Ze square by 4 pi epsilon. Rn ನ ಈ ಕಡೆ ತಗೊಂಡ್ರೆ ಮೇಲೆ ಬರುತ್ತೆ ಇಂಟು, ಇಲ್ಲ ಏನು ಬೇಡ, ಏನು ಮಾಡೋಣ, ಇದನ್ನ ಒಂದೇ ಆಗೋಯ್ತು. mvn ಸ್ಕ್ವೇರ್ ಇದು ಈ ಕಡೆ ಬಂದ್ರೆ ಮೇಲೆ ಬರುತ್ತಾ, ಹೌದಾ, Rn ಸ್ಕ್ವೇರ್ mvn ಸ್ಕ್ವೇರ್ Rn ಸ್ಕ್ವೇರ್ by Rn. ಈ Rn ಇದರಿಂದ Rn ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತಾ, ರೈಟ್. ಸೊ ಏನು ಉಳಿತು, mvn ಸ್ಕ್ವೇರ್ Rn ಉಳಿತು. Rn equals to Ze square by 4 pi epsilon. Equation number 2. This is equation number 2. ಇಲ್ಲಿ ಏನಾಯ್ತು ನಮಗೆ, ಈ Rn square ಕಂಡುಹಿಡಿದು ಬಿಟ್ರಿ. Rn square divided by Rn ಅಂದ್ರೆ one Rn cancels here. So Ze square by 4 pi epsilon equals to mvn square Rn. So from second postulate of Bohr's atom model. Second postulate of Bohr's atom model. So here second postulate, what it says, formula mvn Rn equals to nh by 2 pi. Where the electron is revolving in an atom, where the condition for angular momentum of an electron just becomes equal to nh by 2 pi. In those orbits, electron is revolving. mvn Rn equals to nh by 2 pi. So Vn rules totally. Vn formula. Vn equals to nh by 2 pi. nh by 2 pi. Rn Rn. So ಇದರಿಂದ Vn equals to ಅಂದ್ರೆ nh by 2 pi. mRn ಅಂದ್ರೆ by nh by 2 pi into mRn ಬಂತು. So put Vn in 2. Put Vn in equation number 2. ಇದರಲ್ಲಿ mVn square Rn ಇಲ್ಲದ ಈ ಪ್ಲೇಸ್ ನಲ್ಲಿ ಆಗುತ್ತೆ. m into Vn square ಅದರಲ್ಲಿ ಈ ಪ್ಲೇಸ್ ನಲ್ಲಿ Vn ವ್ಯಾಲ್ಯೂ ಏನಲ್ಲ, nh by 2 pi mRn square Rn equals to Ze square divided by 4 pi epsilon. Z square by 4 pi epsilon. Right? M into n square h square divided by 4 pi square m square rn square. ನೋಡ್ರಿ m into square n square h square 4 pi square m square rn square into rn equals to z square by 4 pi epsilon. Z square by 4 pi epsilon. ಇಲ್ಲೊಂದು rn ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ನಮಗೆ rn ಬೇಕಲ್ಲ, rn ನ ಈ ಕಡೆ ಬಿಡ್ರಿ. ಈ ಉಳಿದ ಎಲ್ಲ ಟರ್ಮ್ಸ್ rn ನ ಈ ಕಡೆ ಬಿಡ್ರಿ. ಇಲ್ಲಿರೋ ಎಲ್ಲ ಟರ್ಮ್ಸ್ ಇಟ್ಕೊಂಡ್ಬನ್ನಿ. m n square h square divided by 4 pi square m square rn. So into ಈ ಕಡೆ ಬಂದ್ರೆ into z e square ಈ ಮೇಲೆ ಬಂದ್ರೆ 4 pi epsilon ಈ ಕಡೆ ಬಂದ್ರೆ equals to ಇಲ್ಲಿ rn equals to rn. Right? So ಇದು ಡಿನಾಮಿನೇಟರ್ ಬಂತು, ಇದು ನ್ಯೂಮರೇಟರ್ ಬಂತು. ರೈಟ್? ಈಗ ಏನಾಯ್ತು ಈಗ ನೋಡ್ರಿ, ಈಗ 4 then pi ಇಲ್ಲಿ 1 pi m ಇಲ್ಲಿ 1 m. Right? So n square h square epsilon naught divided by pi m z e square equals to rn. So rn, radius of nth orbit of hydrogen atom is equals to rn equals to formula in terms of rn equals to n square h square epsilon naught divided by pi m z square. N square h square epsilon naught by pi m z square. So here we used two Bohr postulates of Bohr's atom model. First postulate and second postulate. First step is from first postulate, Fe equals to Fc. Then you find the formula for Fe and Fc, equate the two. Fe is Z square by 4 pi epsilon Rn square. Fc is Mv square by R. So when you are equating the two and cancelling the corresponding terms, here see ಲೇನ್ ಮಾಡಿದ್ವಿ z square by 4 pi epsilon rn square ఇక్కడ ತಗೊಂಡ್ಬಂದ್ವಿ, ಇಲ್ಲಿ ತಗೊಂಡ್ಬಂದ್ವಿ mvn square rn square. rn ಇಲ್ಲೊಂದು rn, ಇವಾಗ rn ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು, ಇಲ್ಲ rn mv square rn equals to z square by 4 pi square. Equation number 2. From second postulate of Bohr's atom model, mvn rn equals to nh by 2 pi. So ಇದರಿಂದ vn ನ ಸಪರೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. vn equals to nh by 2 pi mrn. Put vn in equation number 2. vn mvn square equation number 2 ನಲ್ಲಿ ಅಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಆಗುತ್ತೆ, ಸ್ಕ್ವೇರ್ ಮಾಡಿ you will get this one. So next n square h square by 4 pi square m square rn 4 pi, ಇಲ್ಲಿ pi square ನಲ್ಲಿ pi ಹೋಗುತ್ತೆ. So rn equals to ಏನು ಬಂತು, n square h square epsilon by pi m z e square. This is the expression for radius of nth orbit of hydrogen atom. See, expression for radius of hydrogen atom is rn equals to n square h square epsilon by pi m z square. Right? We got this expression for hydrogen atom. For H atom, for hydrogen atom, Z equals to atomic number or number of protons equals to 1. For hydrogen atom, Z equals to 1. Therefore, expression for radius of nth orbit of hydrogen atom is n square h square epsilon naught divided by pi m e square. pi m e square. Right? So let us find the value for first orbit of hydrogen atom. What is the, see, before finding first radius of first orbit, put h equals to, h is Planck's constant, 6.625 into 10 to the power of minus 34 joule second. What is the value of Planck's constant? 6.625 into 10 to the power of minus 34 joule second. Epsilon naught is 8.854 into 10 to the power of minus 12 Coulomb square per Newton per meter square. Coulomb square per Newton per meter square. 8.854 into 10 to the power of minus 12. Pi equals to 3.142 pi. M is mass of an electron. It is 9.1 into 10 to the power of minus 31 kg. And E is the charge of an electron. 1.602 into 10 to the power of minus 90 coulomb. So what is the value of H? 6.625 into 10 to the power of minus 34 joule second. What is the value of epsilon naught? 8.854 into 10 to the power of minus 12 Coulomb square per Newton per meter square. Value of pi 3.142. Value of m 9.1 into 10 to the power of minus 31. And value of charge of an electron 1.602 into 10 to the power of minus 90 coulomb. So after substituting in these expressions, in this expression, you will get Rn equals to n square into, when you substitute all these values, you will get 0.53 into 10 to the power of minus 10 meter. Once you calculate, after listening to when you are listening to the class, you take the calculator and substitute all the values, calculate, you will get 0.53 into 10 to the power of minus 10. That is Rn equals to n square into 0.53 angstrom. Rn equals to n square into 0.53 angstrom. So where angstrom is 10 to the power of minus 10, right? See, also for first orbit of H atom, n equals to, n is a number of orbit. n andre ಇಲ್ಲಿ ಯಾವ ಆರ್ಬಿಟ್ ಅಂತ, ಫಸ್ಟ್ ಆರ್ಬಿಟ್, ಸೆಕೆಂಡ್ ಆರ್ಬಿಟ್, ಥರ್ಡ್ ನಂಬರ್ ಆಫ್ ಆರ್ಬಿಟ್ ಅದು ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಅಂತ ಕರೀತಾರೆ. n equals to 1. So r1 equals to 1 square into 0.53 ಕೂಡಿಸು 0.53 angstrom. Right? So some errors came, so that's why here I stopped. R1 equals to radius of first orbit of hydrogen atom is 0.53 angstrom. Right? Remember, what is the value for first orbit of hydrogen atom? 0.53 angstrom. How to find? There's a direct formula for finding the radius of different orbits of hydrogen atom is Rn equals to n square into 0.53 angstrom. ಯಾವ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ n ವ್ಯಾಲ್ಯೂ ಆರ್ಬಿಟ್, ಸೆಕೆಂಡ್ ಆರ್ಬಿಟ್ ಅಂದ್ರೆ 2 ಸ್ಕ್ವೇರ್ 4 ಆಗುತ್ತೆ, 4 into that one. ಥರ್ಡ್ ಆರ್ಬಿಟ್ 3 ಸ್ಕ್ವೇರ್ 9 into that one. ರೈಟ್? ಗೊತ್ತಾಗುತ್ತಾ? So fourth orbit 4 square into that one. So you will get you can easily find the radius of different orbits of hydrogen atom. Different orbits of hydrogen atom. How to find? So this is the main expression, n square h square epsilon by pi of e square. ಇಲ್ಲಿಂದ ಬರಬೇಕು, ಡಿರೈವೇಶನ್ ಇಲ್ಲಿಂದ ಬರಬೇಕು. z equal to 1 ಹಾಕಲೇಬೇಕು. ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಗೆ z equals to 1 ಇರ್ತದ. So n square h square epsilon by pi of e square. Suppose ಏನಾದರೂ ರೇಡಿಯಸ್ ಆಫ್ ಫಸ್ಟ್ ಆರ್ಬಿಟ್, ಸೆಕೆಂಡ್ ಆರ್ಬಿಟ್, ಈ ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲಿ especially in while solving the problems you may come across radius of second orbit. So no need to take all these values and calculate. Just remember this formula. Rn equals to n square into 0.53 angstrom. Substitute n equals to 2. So Rn equals to 2 square 4 into 0.53 angstrom. So easily we will get 4 into 0.53 angstrom is 10 to the power of minus 10. So here now I am back to tell you about expression for velocity of electron in nth orbit of hydrogen atom. So now only you learned expression for radius. Yes, what was the final expression you got? Rn equals to n square h square epsilon naught by pi m e square. So now we are going to understand about velocity of an electron in nth orbit. Same procedure. Say consider an electron. Consider an electron revolving in nth orbit of H atom, nth orbit of hydrogen atom, nth orbit of hydrogen atom. This is the nth orbit, this is the nucleus. This is Vn and this is radius Rn, right? So in one length m is mass of electron, m means mass of an electron, m is mass of an electron, Rn is radius of an electron, Rn is radius of an electron, Vn is velocity of an electron, velocity of an electron. So same step from first postulate of Bohr's atom model. Fe equals to Fc, equation number 1. Fe equals to Fc. You learned Fe you got Z square by, in last derivation only you learned expression for electrostatic force of attraction. Fe equals to Z square by 4 pi epsilon Rn square. Fc centripetal force is mv square by Rn. So one becomes equation number 1 becomes, yes, what is the equation number 1 here? Fe equals to Fc. Fe is Z square by 4 by epsilon Rn square equals to mv square n by Rn. Mv square n by Rn. So you bring Rn square to same steps, RHS. Z square by 4 by epsilon equals to mvn square. So this Rn square, when it comes to RHS side, mvn square Rn square by Rn here, one Rn cancels. So you are left with mvn square Rn equals to Z square divided by 4 pi epsilon. Z square divided by 4 pi epsilon. Equation number 2. Z square divided by 4 pi epsilon. Right, next term. Second postulate of Bohr's atom model. From second postulate of Bohr's atom model. mvn Rn equals to nh by 2 pi. mvn Rn equals to nh by 2 pi. So this is the second postulate formula that we get from second postulate of Bohr's atom model. So MVNRN equals to NH by 2 pi. So we just divide equation number 2 by, see, equation number 2 divided by 3 gives equation number 2 divided by 3. Equation number 2 divided by 3 gives. So divide LHS of equation number 2 by LHS of equation number 3. That is M Vn square Rn divided by M Vn Rn equals to here Z square by 4 by epsilon naught into divide ಮಾಡಿದ್ರೆ ಕೆಳಗಡೆ ಬಂದಿರುತ್ತೆ ಇದು ಮೇಲೆ ಬಂದ್ರೆ ಏನಾಗುತ್ತಾ ಕೆಳಗಡೆ ಇರುತ್ತೆ ಆಕ್ಚುಲಿ ಇಲ್ಲಿ ಮೇಲೆ ಬಂದ್ರೆ 2 pi by nh 2 pi by nh. So 2 pi 1s are 2 pi 2s are first thing 2 pi 1s are 2 pi 2s m vn ಇಲ್ಲಿ 1 vn ಇದು rn. So vn equals to z square divided by z square by 2 epsilon naught nh 2 epsilon naught nh. Vn equals to z square divided by 2 epsilon naught nh 2 epsilon naught nh, right? Z square divided by 2 epsilon naught nh. This is the formula for velocity of nth electron of velocity of an electron in nth orbit of hydrogen atom. What is the expression? Vn equals to z square by 2 epsilon naught nh. For hydrogen atom z equals to 1. For H atom z equals to 1. So therefore finally Vn equals to E square divided by 2 epsilon naught nh. This is the expression for velocity of nth or velocity of an electron in the nth orbit of hydrogen atom. So yes, what is the expression you got? Vn equals to E square by 2 epsilon nh. First same steps, equation number 1 same, Fe equals to Fc values substitute ಮಾಡೋದು same expression ಇಲ್ಲಿ ತರ same ಇರುತ್ತದೆ. So ಇಲ್ಲಿ from second postulate equation number 3 2 by 3 ಮಾಡ್ರಿ. So Vn equals to z square by 2 epsilon naught nh. For H atom z equals to 1. So Vn equals to E square by 2 epsilon naught nh. This is the expression for velocity of an electron in nth orbit of hydrogen atom. Watch this video for 2 times so that these are very important for 5 mark section. 5 mark section in your final exam. Definitely will get one question among the 3. ಇನ್ನೊಂದದ 3 ಬರ್ತಾವ ಇನ್ನೊಂದದ 3 ನಲ್ಲಿ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಗ್ಯಾರಂಟಿ ಬರ್ತದೆ 5 marks ಗೆ. So they are very important. Listen and practice. Okay, have a nice day.